And ROC stands for receiving operating characteristic. So it is an ROC curve, and an ROC curve is actually built using true positive rate, TPR, and false positive rate, FPR. And true positive rate is true positives divided by true positives plus false negatives. And false positive rate is false positives divided by false positives plus true negatives. So this ROC AUC curve, oh, sorry, not AUC, ROC curve is built using these true positive rate and false positive rate. And what you really do is that you actually have false positive rate on your x-axis and true positive rate on your y-axis, and you actually plot them. And it builds a curve. This curve is called a ROC curve, receiver operating characteristic curve. And you can see that the more area it covers, so this blue curve, underneath the curve is the biggest area is underneath that blue, and the smallest one is underneath this red line. So the bigger the area, the better your algorithm. And this is when you calculate this area under the curve, that is what you guys have been using, where you say that we are going to calculate the area under the ROC curve. AUC, ROC, area under the curve. This is the area under the curve that we are talking about. And a random classifier that does not predict very well, your area under the curve is usually 50%. Then this yellow, beige kind of is a little bit better. Green is better than beige, and blue has the best.
I see that formula again.
Say that again.
I see the formula again.
You mean this one?
True positive, false negative.
Yeah, true positive rate, false negative rate. False, no, not false negative, false positive rate.
So is it the precision of both classes?
So true positive divided by true positives and false negatives. This false negatives. This is actually true positive divided by true positive and false negative. So this is, let's go back here. So this is true positives divided by true positives plus false negatives. So this is recall.
Oh, false negative. Oh, recall.
Yeah.
Oh, can I see that again? The other one? Oh, false. Oh, okay. Also, it's the recall of both.
Yeah. So false positives, and true negatives. So false positives and true negatives. Yeah. So it is this zero, this no, and yes. Focuses on the actuals. Okay, and this is your basic area under the curve that we find false positive rate. This is area under the curve. AUC is basically a decent metric, not the best. I still prefer precision and recall individually, but area under the curve is also a decent metric to work for when you're doing classification. And if you remember here, recall is also called sensitivity. So recall is also called sensitivity, and then there is this sensitivity. So basically, the recall or true positive rate is sensitivity. And then specificity is when the actual value is negative, how often is the prediction correct? So true negatives divided by actual negatives. That is specificity. Again, some terminology that you should kind of pay a little bit attention to. Sensitivity is recall or true positive rate. They might ask you sometimes that. Specificity, they don't really ask that much, but sensitivity, they might ask you. But who knows, they might ask you specificity also. So just remember these.
Wait, hold on. Then are these all different versions of recall?
They are kind of based on recall. So sensitivity is based on is actually recall, and I want to say specificity is one minus recall. Specificity is true negative rate. Oh, sorry, false dismissal rate is one minus sensitivity, and false alarm rate is one minus specificity. And these are just some formulas that you just have to kind of. I can share this presentation with you guys so that you guys can have a copy of this. But just keep that in mind that this is something that that they might ask, and just memorize these, pay a little bit more attention to these, and do that check. Okay, so here are the two scenarios. Medical diagnosis model for disease detection. Scenario: a model is trained to identify the presence of a disease such as cancer in medical scans. So what do you want to focus on?
Recall.
Recall. And the second one is a spam detection email filter. A model is designed to classify emails as spam or not spam. Generally, what do you want to focus on? Here, you want to focus on precision, so that when the emails that you are removing or not showing the person are truly spam. All right. Any questions on this?